Hi, it's Mr. Anderson, and this is Chemistry Essentials video 34, which is on electrochemistry. In electrochemistry, what we're doing is generating current. We're actually generating moving electrons in a reaction, or we're requiring those. And so if you don't understand what a redox reaction is, you may want to look at that video. But a great example of electrochemistry could be a lemon battery. All we're doing is inserting two pieces of metal into the lemon, and we're going to generate voltage. Now, you'd have to hook it up to a pretty sensitive voltmeter to measure that voltage, but if we hook a number of lemon batteries up in series, we could actually light a little LED. And so electrochemistry is really the study of redox reactions, and we're separating the reduction and the oxidation portion in space or time. Now, when you do that properly, you've created something called an electrochemical cell. That cell could either be a galvanic cell. It's sometimes also referred to as a voltaic cell. An example could be a battery, and that's going to generate current. Or we could have an electrolytic cell, and that's going to require current. An example could be a rechargeable battery. And so what we're doing, remember, is separating the reduction and the oxidation. In review, reduction is the gaining of electrons, and oxidation is the losing of those electrons. And what we're doing is tapping the flow of those electrons. Now, the metal is either a cathode or an anode. And a quick way to remember that is that reduction always occurs at the cathode and oxidation at the anode. Or a better way to remember that is that the consonants R and C are going to pair, and the vowels, the O and the A, are going to pair as well. And so what we can do is analyze this cell. We can break it down into its two half reactions. We could figure out the potential of those two half reactions and then simply add them together to figure out the standard potential. So how much energy that cell could produce or require if it's electrolytic. Now this would be at STP, standard temperature and pressure. And so if we have